Space is vast, it's full of mysteries. From the smallest particles to the largest galaxies, the universe is a treasure trove of the unknown. Scientists have been trying to unravel these mysteries for centuries, and yet every discovery seems to open up even more questions. One of the most intriguing mysteries in the cosmos is the concept of the Gravastar. One of these mysteries is the Gravastar. A Gravastar, short for gravitational vacuum star, is a theoretical object that challenges our understanding of black holes and the nature of gravity itself. Imagine a super-dense object, even denser than a neutron star. That's a Gravastar. They're theoretical. Unlike black holes, which have a singularity at their core, Gravastars are thought to have a core made of dark energy, surrounded by a shell of normal matter. This unique structure could have profound implications for our understanding of the universe. But they could change how we see black holes. Gravastars are weird. They don't behave like anything we've ever observed. Instead of pulling everything in, like black holes, Gravastars might actually repel matter and energy, creating a kind of cosmic barrier. They challenge what we know about gravity. The existence of Gravastars could mean that our current theories about gravity and the fabric of spacetime are incomplete. This could lead to new physics, new equations, and a deeper understanding of the universe. Black holes suck in everything, even light. Their gravitational pull is so strong that nothing can escape once it crosses the event horizon. This makes them some of the most fascinating and terrifying objects in the universe. Gravastars, on the other hand, might push back. Instead of an event horizon, they could have a boundary that repels matter and energy, acting as a cosmic bouncer that keeps everything at bay. They could be the ultimate cosmic bouncers. This repelling force could prevent the formation of a singularity, which is the point of infinite density at the center of a black hole. Instead, the core of a Gravastar could be a region of dark energy, balancing the forces of gravity and repulsion. The name Gravastar comes from gravitational vacuum star. This name hints at their strange nature. They are thought to be a vacuum-like region surrounded by a shell of matter, creating a unique and mysterious object in the cosmos. This name hints at their strange nature. Gravastars are not just another type of star or black hole. They represent a completely different kind of celestial object, one that could change our understanding of the universe. They're like bubbles of energy pushing against the crush of gravity. This balance of forces could create a stable structure that defies our current understanding of astrophysics. If they exist, Gravastars are rare. Finding one would be like finding a needle in a cosmic haystack, but their discovery could revolutionize our understanding of the universe. But their existence could solve some big problems in astrophysics. They could provide answers to questions about the nature of dark energy, the behavior of gravity, and the ultimate fate of stars. They might even hold the key to understanding the fate of collapsing stars. Instead of forming black holes, some collapsing stars might become Gravastars, offering a new perspective on the life cycle of stars and the evolution of the universe. Einstein's theory of general relativity governs the universe. It says gravity warps spacetime. Massive objects create a dip in this fabric. This dip is what we feel as gravity. Black holes take this to the extreme. They warp spacetime so much that nothing escapes. Gravastars, however, offer a different perspective. They suggest that at extreme densities, something else takes over. Instead of collapsing endlessly, like in a black hole, matter inside a Gravastar might transform. It could become a state of exotic energy. This energy would exert an outward pressure, counteracting gravity's pull. This outward pressure is key. It prevents the Gravastar from collapsing into a singularity. Instead, it creates a shell-like structure. How does a Gravastar form? It starts with a dying star, much more massive than our sun. As the star runs out of fuel, it can no longer support itself against its own gravity. The core collapses. This collapse happens incredibly fast. If the collapsing core is massive enough, it could form a black hole. But some theories suggest another possibility. During this collapse, if the energy density reaches a critical point, a Gravastar might be born. The collapsing core would transform into a shell of exotic energy, preventing further collapse. This process is still theoretical. Scientists are working to understand the exact conditions needed for Gravastar formation. What lies inside a Gravastar? This enigmatic cosmic entity has puzzled astronomers and physicists alike for years. It's a question that continues to intrigue scientists. Theories abound, but concrete evidence remains elusive. The interior of a gravastar is a realm of extreme physics where the known laws of nature are pushed to their limits. At the heart of a gravastar there might be a vacuum, a region devoid of matter. This vacuum is not just empty space, it's a fascinating and complex phenomenon. This vacuum is not empty space. Instead, it is theorized to be filled with a special kind of energy known as dark energy. Dark energy is a mysterious force that is believed to be responsible for the accelerated expansion of the universe. Its presence within a gravastar adds another layer of intrigue. Surrounding this vacuum is a shell of ultra-dense matter. This shell is incredibly thin but incredibly strong, a paradox that challenges our understanding of material properties. This shell is incredibly thin but incredibly strong. It's this shell that prevents the gravastar from collapsing under its own gravity. It's this shell that prevents the gravastar from collapsing. The properties of this shell are still a subject of debate among scientists. Some researchers propose that it could be composed of exotic particles or even quantum fields. But it's clear that the interior of a gravastar is a place of extreme conditions, unlike anything we experience on Earth. The temperatures, pressures, and energies involved are beyond our current technological capabilities to replicate or fully understand. As our observational tools and theoretical models improve, we may one day unlock the secrets of these mysterious objects. Until then, the gravastar remains one of the most fascinating and enigmatic phenomena in the cosmos. Section 5: Cosmic Clash, when gravastars collide. The universe is a dynamic place. Objects collide, creating spectacular events. But what happens when two gravastars collide? It's a question that sparks the imagination. The collision of two gravastars would be a cosmic event of unimaginable energy. As the two gravastars approach each other, their intense gravitational fields would interact. This interaction would distort the fabric of spacetime, creating ripples known as gravitational waves. The collision itself would release an enormous amount of energy, possibly even more than a supernova. This energy could be released in the form of gravitational waves, light, and other particles. Section 6: Gravastars versus Black Holes, a Celestial Showdown. Gravastars and black holes are both fascinating objects. They captivate the imagination of scientists and enthusiasts alike, drawing us into the mysteries of the cosmos. They represent the extremes of gravity, showcasing the incredible forces at play in our universe. But they have key differences that set them apart in the cosmic landscape. Black holes are regions of spacetime where gravity is so strong that nothing, not even light, can escape. This immense gravitational pull warps the fabric of space itself. They are formed from the collapse of massive stars, often following a spectacular supernova explosion that leaves behind a dense core. Gravastars, on the other hand, are hypothetical objects. They exist primarily in the realm of theoretical physics. Yet they offer an intriguing alternative to black holes. They are thought to be formed from the collapse of even more massive stars, potentially those that are much larger than the ones that create black holes. Unlike black holes, gravastars have a surface. This surface is theorized to be composed of exotic states of matter, making them fundamentally different. The key difference lies in their event horizons, or rather, the lack thereof in gravastars. Black holes have a point of no return, the event horizon. This boundary marks the limit beyond which nothing can escape the gravitational pull. Anything that crosses this boundary is trapped forever, unable to return to the observable universe. Gravastars, in theory, do not have an event horizon. Instead, they possess a different structure that prevents the formation of this boundary, leading to fascinating implications for our understanding of gravity and spacetime. Section 7: Unveiling the mysteries, gravastars, and the fabric of spacetime. Gravastars, if they exist, could hold clues about the nature of spacetime. They challenge our understanding of gravity at its most extreme. The existence of gravastars could help explain some of the mysteries surrounding black holes. For example, they could provide insights into the information paradox, which questions what happens to information that falls into a black hole. They could also shed light on the nature of dark energy, the mysterious force that is accelerating the expansion of the universe. Some theories suggest that the vacuum inside a gravastar could be filled with dark energy. Section 8. The search continues, seeking evidence of gravastars. Despite their potential significance, gravastars remain theoretical objects. Scientists are actively searching for evidence of their existence. One way to detect a gravastar would be to observe its gravitational effects on nearby objects. Gravastars, like black holes, would exert a strong gravitational pull. Another way would be to search for the unique signatures that gravastars are predicted to emit. For example, the collision of two gravastars is expected to produce a distinct pattern of gravitational waves. The search for gravastars is a challenging but exciting endeavor. It requires pushing the limits of our technology and our understanding of the universe. Section 9. Conclusion: Gravastars. A new frontier in astrophysics. Gravastars represent a new frontier in astrophysics. They challenge our understanding of gravity and the nature of the universe. While they remain theoretical, the possibility of their existence is both intriguing and exciting. Gravastars could hold the key to solving some of the biggest mysteries in astrophysics. The search for gravastars is a testament to human curiosity and our desire to understand the cosmos. As we continue to explore the universe, we may one day uncover the secrets of these enigmatic objects.